Gotta make sure it's recording. Yeah, it is. Okay. So, sorry, it might be a little bit dark. I'll try and do the other ones after your midterm in daylight. So hopefully that helps. I have like a little spotlight that Trent uses because he does videos in his office, but I don't think I have it quite set up as professionally as he does. But, so first I'm going to do parallel and perpendicular lines. So again, we're just going to keep on working with the same equation and just keep on making sense of it. So we talked about how this represents the slope, and lines are parallel if, and then this is the, it looks like an 11, but it's just two lines. That's the symbol for parallel. So two lines are parallel if the slopes are the same. So right here we have y equals 2x plus 7. So if we wanted to find a slope that is parallel to this one, then the slope of a parallel, so I'm just putting the parallel symbol next to m for slope, would have to be the same as 2. So then 2. So if I had a slope of negative 7, if I wanted a parallel one to this one, I shouldn't have put that symbol there, sorry. So if I have a slope of negative 7 and I want a slope of a parallel line to this one, then we just want it to be negative 7 again. If I have 1/4 as the slope, then a parallel line would be 1/4, and that's it. So that's parallel lines. Now, if two lines are parallel, then we know that parallel means that they'll never cross. So say we have y equals 1/3 x minus 6. So in your head, think, what would the slope of a parallel line to this line be? Okay, so then it's going to have to be 1/3 because it has to be the same. So I'm just going to make up another equation where it's y equals 1/3 x plus 4. So then I'm going to go down 6 and then up 1/3. Okay, there's 1, and then I'm going to go up 4, and then I'm going to go up 1/3. So I start at 4 for my y-intercept, up 1/1, 2, 3. So if my lines were perfect, which they're not, but if they were perfect, they would be parallel, and so that means that they will never cross. Okay, so what if I have something like this? Okay, so if I have this, what if I told you that these two lines are parallel? Well, you can't just look at this immediately and say, yeah, those lines are parallel. You would have to have them both in slope-intercept form because that is the only way that we can determine the slope, is if it's set equal to y, so y is alone. So if the slope is next to x, then we can tell, or I'm sorry, if y is alone, then we can see what's next to x is our slope. So even if it were written like this, which I should have said in the other video, if I have y equals negative 8 plus 4x, here the slope is 4 and the y-intercept is negative 8 because the slope is always attached to x because we're multiplying because that's how much it's changing by. So that's what they'll often call the rate of change, and that has to be multiplied by. So I can't really think of a good explanation why that's the case, but the slope is always attached to the x. And then negative 8 has to be alone because it's the y-intercept. Now I can have an explanation for why that's alone because the point for the y-intercept is always 0, comma, whatever that number is, so negative 8. So it's always just 0 and then that number. Okay, so that's just a side note. Okay, so for this one, I'm going to get y alone. So for this one, I have to get y alone. This one, y is already alone. And then I'm going to add 4x over. Those are not like terms because this has an x and this does not. So I'm going to have 2y equals. Now, I like to write the x first. Since the x is first in that one, I always write x first. So 4x plus 14. Again, they're not like terms because this has an x and this does not, so I cannot add them together. Okay, y is not alone yet. It has a 2 being multiplied to it. So I have to divide everything by 2. It can't just be one thing. An equation means that all things are equal. So we have to do the same thing to every term. Okay, so then y equals 4 divided by 2 is 2x. 14 divided by 2 is positive 7. So that's our equation, and this was our other equation. So now we can determine if these are parallel. And yes, they are, because the slopes are the same. Now, they're going to be parallel if the slopes are the same and the y-intercepts are different. If the y-intercepts were the same, then it would just be the same line. So they wouldn't be parallel. Okay, I think that one's good for parallel.